Okay, hi everyone. We're back in our statistics class notes. We're now in section 2.2, page 13 of our notes. So section 2.1, we learned how to visualize numerical data by learning about three different plots: a dot plot, the histogram, and the stem plot. In section 2.2, we're going to learn how to summarize the important features of a numerical distribution. So we talked about this quickly before, but there are three key features. These are shape, center, and spread. So the first of these is shape. There are three basic characteristics of shape. Is the distribution symmetric or skewed? How many mounds appear when I look at the data? And are unusually large or small values present? So first let's talk about whether it's symmetric or skewed. A symmetric graph will look similar to this. This guy's perfectly symmetric, of course, where the left and the right side are the same, but you don't have to be perfectly symmetric to say a graph is symmetric. They just need to be roughly the same. So we have a nice symmetric graph like this. A skewed graph will look more like this, where most of the data is on one side with a long tail. So you have most of the data over here and you got a tail on this other side. Now, when we do have a skewed data set, we like to say which way the tail is. So this example is skewed left. The tail is going off to the left. There's not as many data values over here, so there are some sort of unusual data values over here. Most of the data is over here. I'm going to go on to page 14 also. So for example, in example 16, we want to describe the shape of each graph. Hopefully, you run your finger over this, you can kind of see, yes, this has a tail to the right, so this is skewed right. It is not symmetric, it is skewed to the right. This guy, if I'm running, I have maybe some outliers, maybe part of a tail. There's nothing in these bends here, but if I were to run my finger over this, I would definitely say that that's skewed left with maybe outliers to the left also, but we'll talk about outliers a little bit more later. And this is an example of a nice symmetric graph. This is a symmetric graph. Okay. The next thing about shape that you want to talk about is modes. Now, modes classify data by how many mounds you see, how many mounds are present. So unimodal graph would be one main mound like this. This is symmetric, and unimodal means one mound. A bimodal graph has two main mounds. Looks something like this. Okay. Once we get into more than two mounds, we don't really talk about trimodal or anything like that. We just say multimodal. There are more than two mounds. Mounds can be different height. Bimodal and multimodal data usually, or they may, indicate existence of there's different groups within the data. You can imagine like we're plotting heights here of people, and this might indicate where more of the women are. This might indicate where more of the men are, just because men are typically taller. So you see the taller heights over here, the shorter heights over here. So we might have two groups in this. In this case, it may be preferable to separate the data into the two groups and provide separate graphs for each group. For examples like I just talked about, plotting men's and women's heights together, or think about plotting afternoon and evening sales at a restaurant together, right? Those are going to be quite different as well and probably give you more than one mound. So example 17, what shape would you expect to see in a histogram of the following data set? So if I said, what would you expect to see for GPA of college students at Harvard? So we would think, well, we're going to have a lot of students with really high grades at Harvard, and then maybe a few with lower grades, so we're probably going to see skewed left and unimodal. If I were to look at SAT scores nationwide, those are actually set to be symmetric and unimodal. So typically people are in here, but you have some really low scores, some really high scores. And then let's say the income of USA residents. Well, most of us, somewhere down in here, and then there's a few people that make a ton of money way out here. So this would be skewed right and unimodal. The last type of distribution I want to talk about real quick is one that we'll see a lot, or one that we'll see later. So I just want to bring it up, not a lot later, but we'll see it later. So this is an example of last digit of Social Security numbers for a random sample of students. Social Security numbers all end in either 0 through 9, right? And there's really no one that's more than another, so we'll see a flat top. They basically all can kind of equally come up. So this is called a uniform distribution. It's symmetric, but we don't really see any mounds at all, so we don't say it's modal at all.